Hi, everyone. I'm Motion Mike Miller. I'm a solution consultant with Rockwell Automation. Welcome to Motion in Minutes, where we dig into the features and capabilities of our integrated motion solution and discuss how they can save you time and money. In this episode, we're focusing on the Axis Test Mode feature in Studio 5000 Logix Designer software. We understand that having the ability to test and refine your application code in a simulation is very desirable for machine builders. There are often delays that lead to a compressed timeline for machine commissioning and debugging. Wouldn't it be nice if we had the ability to test our code before having access to the machine or even physical hardware? In version 35 of Logix Designer software, we released a feature that provides a low-fidelity simulation of an axis of our Ethernet-based motion, intended to help you with testing your application code. In the past, you may have tried to use a virtual axis for this, but that likely required modifying your code to support certain instructions, and that's inefficient. With the axis test mode feature, the axis appears as if the hardware is present, and many of the commonly used backing tags of the axis respond as if the axis were present. All you need is either a physical Logix controller or a licensed instance of our FactoryTalk Logix Echo software. It's our next generation controller emulation software. No physical kinetics drives or motors are required.
Let's dive in. I've created a controller project in V35 of Logix Designer software, which includes an axis of motion and the related Kinetics 5700 drive. There's also a virtual axis. Note that Circos and analog axes are not supported in this feature. I've added some safety I/O modules to clarify what can and can't be simulated in V35. In the axis properties, I've added a few cyclic parameters that will likely be used for the actual machine commissioning. Finally, I've included a motion program as an example of code testing using the Axis Test Mode feature. I also have a safety program to show what works and what doesn't work in V35. Now it's time to test my programs. If I had a physical Logix controller available, I could download my project to it and perform these same steps. But if you're like me and you travel a lot and have no hardware available, you can use our FactoryTalk Logix Echo software to emulate your Logix controller. With Echo, I can add my controller using the ACD file or the controller project we just created. This way, it will choose the matching controller and slot accordingly. I'm going to use the default loopback connector for the IP address. Now I can download my project to the Echo controller. I'm going to leave it in the program mode for a moment. The blue indicators on the motion group and the axes tell me that the axis test mode feature is active and my axes are being simulated. With a physical controller, you would have to put the axes into test mode and the axis properties while offline. But with Echo, they automatically go into test mode. You can see that the motion group is synchronized and ready. The axis is in the stop state and not inhibited by the digital enable input that's configured by default or the safe torque off inputs. These are all bypassed in axis test mode in V35. Down below, you see that the drives are in the running state, so we're ready for motion. You may have noticed that the safety input and output modules are in error because they are not present in Echo. So we can simply inhibit the module connection in each of these and the errors go away. We'll clarify how you can simulate I/O later in this video. So now we have I/O okay, even though there's no physical hardware present whatsoever.
Now we're going to take a quick look at the motion program that we provided for code testing. So essentially, there's a state program that steps the machine through resetting any axis faults, enabling the axis, homing the axis if needed. And then we do motion things. We gear the physical axis to the virtual axis, and then we command the time cam on the virtual axis. Next, there's a stopping section where we stop the virtual master, drive the axes to a stop, disable the camming, and then command the axes to disable. So let's put the controller into run mode. We'll open up the trend, drag it over to the side so we can see both the trend and the code executing. I'll start the trend. It's going to show command and actual position, which in the low fidelity model are essentially the same. I'll issue the start command in my code. And there's the time cam profile showing what we programmed. Again, these are all things that you would want to do while you're commissioning your machine. You want to make sure that your code sequences properly. You want to make sure that you can trend certain parameters. Note that we've used common backing tags in the axis, such as the servo action status, axis home status, gearing status, and such like that. Instruction in process bits. Again, all things you'd want to do during code commissioning. Now we'll stop the axis. And stop and close the trend. Let's go into our safety program and see what V35 lets us simulate. I've got an input from our safety input module and an output from our safety output module. I can toggle the input bit since there's no safety connection made to a physical module, and then the output bit turns on. So you can simulate safety code and most of the safety instructions of V35, but what you cannot do is simulate the safe off connection to the drive or the advanced safety instructions in V35. Those came in V36. So let's dig into those and see how Axis Test Mode lets us commission a system that includes these features as well. In V36 of Logix Designer, we get the ability to test the advanced safety functions brought to us with the ERS4 drive and the GuardLogix safety controller. First, we'll start with the SFX, or safety feedback instruction, which brings a safety encoder into the controller's safety task. This can come from a kinetics motor that includes a safety encoder or our 843ES safety encoder. Then maybe you'll implement the safely limited speed instruction, or maybe the safe operating stop instruction based on your application needs. There are 7 advanced safety instructions available today. These instructions can be difficult to implement when you're just getting started with them, so having the ability to test them without having access to the machine or the hardware present is useful and a huge time savings. Now, let's watch a demonstration of how Axis Test Mode can be used to verify your logic when using these advanced safety instructions.
Today's demonstration uses FactoryTalk Logix Echo V3 and Logix Designer version 36. Let's say I'm a controls engineer at a machine builder and we're building a winder. Maybe it's early in the development cycle, or there have been some supply chain delays, or maybe the machine build just is taking longer than expected. But I'd like to test my motion and safety logic in parallel with the development rather than being squeezed at the end in order to meet the ship date. Here's my winder project, and I'm using an Echo controller to test my logic. It's a single axis system that might represent a tire manufacturing cell or a print roller, but for today's demonstration, it's a spindle on my winder unwinder. I've got a Kinetics 5700 ERS4 drive chosen because it includes some advanced safety capabilities. And I'll be using the safety encoder that's provided in my VPC motor that I chose for my spindle. You can see that the spindle axis is safe torque off inhibited right now because it's waiting on some safety permissives that aren't made. You'll also notice that there's this 442G MAB unit that isn't connected, and that's basically a safety gate interface, which we'll talk about shortly. My safety task, you can see I've got several programs and a whole bunch of routines, and it's a fairly complicated safety system. So you can imagine why I'd want to get in and test the code, see how it responds to various faults and recovers. This is the SFX instruction, and it's rather the glue to the advanced safety application. It translates the safe encoder that comes from my Kinetics ERS4 drive, brings it into the safety task, and then puts it into user units for me as well. And in this demonstration, I'm using degrees, but it could be anything. And this is my Emulate 3D model. This is the 442G MAB unit that I mentioned. It's the safety gate interlock. So you can imagine this is used to protect an operator from getting into a fenced-in area. Safety gate might be closed and locked with this unit. It has the ability to lock the operator out, but yet provide access on proper demand. It's protecting the operator from this rotating load in this example. These are various requests that I can make to test my system, and then the status comes from the Logix safety task to indicate the resultant of these requests. I can see the speed in degrees per second. I can tell the position of the rotating member here on this part of the display. And we'll get into some of the other pieces later, but essentially I've got my reset, start, and stop buttons here to command my machine. So I'm going to go ahead and connect it to the system. This is the connection to Logix. So I'm starting the connection to Logix, and you'll see that the MAB are tags in my model, and it's going to make a class 1 connection to pretend that it's the safety device on Ethernet, that this 442 device would be in person. But again, I have no hardware in front of me, so it's simulating that. It made the connection went green. But what does that mean in Logix? Let's bump back to Logix for just a second here. We see now, after a second here, that the 442 will go running and that my IOOK is now satisfied. So it believes that there is a safety gate out there because Emulate is providing that functionality to us. Fantastic. Now we're back in Emulate 3D and we're going to start the model. So I'm going to reset and run the model. I'm going to enable some trends here in my model so you can sort of see what's going on. We've got our actual speed, we've got some other pieces that we'll talk about, and then the STO, which is off right now. The safe torque off outputs from Logix are off right now. I'm going to reset. Actually, I'm not going to reset. I'm going to stop and home the axes. And you'll see now that the position, which rolls over at 360, so it could say 0 or 360 at any given time, and this are both aligned. That aligns my safety encoder to my motion axis. So now I'm going to reset and start the system. And it's going to ramp up to the application speed, which is very slow, but shows well over Teams and in videos over the internet. It's going to ramp up to the commanded speed, the application speed of 100 degrees per second. Now, I can't get into the dangerous load. I can't even open the gate right now. It's locked, as you can see by the unlock bit being false. Therefore, the lock is activated. I can't get in or do anything because that's too dangerous. I can e-stop the system, and it's going to do by default what's called a safe stop 1. A safe stop 1 is defined as ramping down to 0 speed under control and then turning off the STOs to disable the drive and incapacitate the drive, if you will. So it indicates that safe stop 1 worked properly and the drive is now disabled. I could get in and do some things if I unlock the gate, but I'm not going to do that right now. I'm going to reset the system, start it back up, put it back to my application speed of 100 degrees per second. I'm going to demonstrate the safety function of the safe limited speed request. So I'm going to request that it goes to a safe limited speed, and a risk assessment would determine what that speed is. In my demonstration here, I have to be below 20 degrees per second, whatever that does to make it so it's safe for the trained operator to be around. As long as I stay under 20 degrees per second, I'm safe. So you can see I'm commanding 15, which is below 20. So I'm running at safe speed, and it indicates that safe limited speed is okay. I still can't get in though. So what I have to do is grab the operator pendant, and I squeeze that pendant. I'm not going to get into how it works, but it's got some neat features in it as well. And now I can actually open the gate, get in and do the tasks that I'm trained and allowed to do while the axis is still spinning at the safe limited speed. So let's say it's a print head and there's some goop on it from ink that dripped or whatever. I can wipe that off. Let's say it's my winder and I have to re-thread the needle. So I can go in and do that at safe speeds. Again, I'm trained, a risk assessment was done, et cetera, et cetera. So I'm done with that task. A little bit hard to close the door in Emulate 3D. So now I've closed that. I'm going to flip the lever back up, and it's still unlocked. So I'm going to press the go ahead and lock button. And you'll notice now that the unlock goes false. A little hard to see in yellow. But it will still fault if I do anything but now let go of the pendant. So I'm letting go of the pendant. We're still at safe speed. I can now turn off the safe limited speed request, and we're back without any faults to full speed, 100 degrees per second. What did that do? Well, 10, 15 years ago, before safe speed, I would have had to have locked out and tagged out that machine. I would have had to stop production, gotten my power turned off, all sources of energy turned off, gone to the lock, and put a lockout tagout tag on there with my name, and then possibly scrap product, and then rethread the needle, and then restart and rehome. It could have taken 60 minutes, 30 to 60 minutes on average for me to perform that simple task with lockout tagout as my only tool. But with the advanced functional safety capabilities we have today with these ERS4 drives, it took a few seconds to do what I had to do. And we never stopped production. We were at reduced capacity, but we didn't stop production. It's fantastic, the capabilities that the advanced safety brings to our manufacturers.
There's so much more, but that's all I have for you today on the topic of Axis test mode. I mentioned that there are many ways to simulate your machine I/O when you're testing your code. For smaller systems, it can be as simple as bit toggling in Logix Designer. If you've got more I/O, maybe you can build a simple HMI application to simulate I/O and step through the machine. Our Echo software supports an API, or Application Programming Interface, with the Software Development Kit, which can be used to simulate larger systems. And as you saw in the video, Emulate 3D is a very elegant way to simulate machine I/O and devices and step through your code. Where can you learn more about Axis Test Mode? Go to our literature library at rock.auto/literature and search for motion-UM003. That's our user manual for the integrated motion on Ethernet IP solution. It's going to show you the features and limitations of Axis Test Mode, as well as the differences of what you can do in version 35 versus 36 and newer in Logix Designer. Where can you learn more about the advanced safety instructions? Search for 2198-RM001 on Literature Library. That's our user manual for the safety instructions. Finally, where can you get some hands-on time with these topics? There's an advanced motion lab available in our on-course environment that includes both Axis Test Mode and the advanced safety instructions. So reach out to your Rockwell Distributor sales team and find out how you can get a reservation to learn more about these time-saving features. Thank you for your time, and I hope to see you again on Motion in Minutes with Motion Mike Miller.